I think that you're most likely going to discuss the solutions with your team leads or section leads. I think that the coding challenge is actually, I believe it's something more new that we're rolling out. And don't worry if you didn't make it far. It's the first coding challenge of the of like your term. It's really not a big deal to not make it far. No one's good at them at the beginning. And and you know what, I could definitely say they get easier, especially after we go through a few weeks of this and kind of get our algorithm brains pumping, and especially hopefully some of the stuff we'll discuss today will kind of get us thinking in how to approach these solutions better. Yeah, I wish we all could be the best right away, Christian. But then engineers won't be as valuable, right? So we all chose to kind of deal with the pain.
I'm not watching. I'm just kind of.
All right, a few more seconds and we'll get started. Also, James, not a bad idea. Hacker ranking every morning. Definitely a great way to kind of, I don't know about the morning, but just in general, like trying to do a hacker rank once a day isn't actually a bad idea at all. I apologize if the sound just it just came through the speakers of anyone. Okay, cool. So, like I said, I hope everyone had, I want to say a good time with the coding challenge, but I'm pretty sure that's a little facetious of a choice of words. So, um, and don't worry if you feel like it was a tough challenge. It's supposed to be tough at first, and you know, as we get better, these things get a lot easier. David, I love that emoji so much. But okay, so other than that, how are the assignments going? I'm curious to know. I'd like to get a poly going just to kind of get a gist as how is the project. And I'm going to create a couple of options for us, and I'd like to hear kind of how we're all doing. Crushed it. We need more hacker ranks. All right, let's add these options. And let's also make it anonymous. Okay, so let me know how the projects are going. So when we ended the guided project on Tuesday, I suggested that a good place to end would be kind of halfway. So right before things started talking about kind of functions and arguments into functions, classes, we didn't have to. You didn't have to necessarily go that far. I know some people probably already did. Love to see this. This is amazing. And we could spend a couple of minutes talking about some things, but the beginning of this lecture is going to talk a little bit more about some more Python fundamentals. Then we're going to go over some problem solving techniques, and then we're going to, as a group, do our first algorithm together. My HackerRank score. Um, I don't really actually use HackerRank as much. There's a couple of other websites that I really like when I practice for interviews when I'm looking for new work. I really love this website, um, but mostly because when I haven't done interviews in a while, but HackerRank when I was in school was kind of I don't think it was as elaborate as it is now. Now it's like a lot more souped up. I think before it was mostly just like you could do those challenges, but you had to pay for them. You can't like a company would use them. But an interview bit was kind of like uh, more open for people to do challenges in like a really nice kind of coding environment. So I always love that. Okay, so it looks like I love these numbers. If you haven't started yet, don't worry. You still have the weekend to finish everything up, but definitely try to get started as soon as possible. Finished halfway, that's great to see, and love to see that people crushed it. Um, so if anyone has any like burning questions, we could definitely maybe answer one or two right now. But in the interest of time, if there's only a few people who have any questions, they could just message me, and I could help out, or your team leads over the weekend or during your kind of office hours should be able to help you out on those things. Um, so without further ado, I'd love to get started on today's topics. So we're going to, this week, we are talking about Python fundamentals. We're talking about both Python fundamentals and kind of computer science fundamentals. So today we're going to finish off talking about Python. We're going to talk about functions and arguments that you can pass into functions. We're going to take a look at a couple of examples there. And we're also going to review a bit of a complicated concept that is very important in Python about how variables get passed around in the code. And after that, we're going to then take a look at the Lambda problem-solving framework, which we've developed and took a big sort of inspiration from a very famous problem-solving framework called the Polya framework. So we're going to take a look at that, and we tailored the Lambda framework to be a lot more focused on you guys, on tech, on specifically solving kind of real-world problems. And we're going to apply that today, and hopefully throughout the entire kind of curriculum, we're going to keep applying it. And eventually you're going to apply that in your own examples when you do these HackerRank challenges, when you're at work, when you're interviewing, throughout your whole life, hopefully. So let's get started. Let's take a look at functions in Python. So here we're back in VS Code, and we're sort of trucking along like we did last time through some examples. So defining functions in Python is, again, also pretty straightforward. To create a function, you just have to type in def, and then you need to come up with a name for your function. The comment above says create a doubling function that passes Rx by value. We'll explain what this last part is, but let's create a doubling function. So you pass in a number and it will double that number. So maybe let's call this double x, for example. So this really pretty simple. We have to do x times 2, and it should double it. Now, obviously, we all know what is, obviously, this isn't going to do what we want unless we're actually returning something out of it. So to return out of a function, all you have to do is type in return. And take a look at the tabbing once again. Once again, to define all the code that's within the function, we have to add tabs, just like we did with for loops on Tuesday. And this will treat the code as in the scope of the function itself. So whatever code is tabbed with kind of on this level will all be treated as code within this function. So as soon as we're here and we type in double 5, we're no longer in the scope of the function anymore. We're on kind of the same scope here, so we can go ahead and run this code. So if we want to do print double 5, we should definitely see us outputting one solid. Not sure what all this was, but oh, you know what it is? It's my virtual env for the people who were in my instructor hour yesterday. It's activated. Either way, here it is, 10. So pretty straightforward. Once again, def is the key word to define a function, name, and parameters. You can pass in more if we want, but we'll talk about passing more arguments in a little bit. Okay. So now let's do kind of the same thing, but there's this passes args by reference thing that's kind of different. So let's first define the function, and then we can go ahead and talk about what we're talking about here. And Dustin is spoiling a little bit, but essentially we are going to talk a little bit about pointers for people who are familiar with the topic. It's not quite pointers, it's kind of Python's. We could kind of think of it as pointers. It's not quite literally the same as maybe something you would encounter in C. Cool. So let's instead of define a doubling function that passes args by reference, let's actually edit this comment a little bit. And let's say define a doubling function that doubles every item in a list. So instead of just one number, we can pass in a list, and maybe with like some simple for loop, we could double every value. So let's say double list. Let's call this list li. And I won't use list comprehensions here. I'll just do this. So we're going to define a for loop in the range from 0 to the length of list. And in it, every item, we could just do simply this. Start multiply equals 2. So we're multiplying and we're assigning the value. It's essentially the same as li I times 2. Does anyone see kind of the glaring difference between these two functions right now? So if I were to do print, let's say new list equals 1, 2, 3, 4. Does anyone see kind of like the biggest difference between these two functions? And will this work? Yeah, what about return? There is no return here, right? We're not doing return li. It's a good point. But we actually are going to see in a second. We actually don't. Well, yeah. There's definitely a for loop, but Sean, is that how you pronounce your name? Sean Sion. I'm not fully sure if I'm pronouncing it right. But Sean, it's Sean, right? I might need a second thumbs up. Okay, cool, awesome. But Sean's got the right idea. There's actually no return. We actually don't need this return. Let's take a look at what's about to happen. Let me clear this and run this one more time. Oh, I apologize. We're not returning anything, so it outputted none. But let's print new list. So let's print it here. We'll run the function. And let's print new list one more time. And as we can see, the original list, 1, 2, 3, 4, has somehow been mutated to 2, 4, 6, and 8. And now we have to figure out what exactly is going on here. And it turns out that this is kind of the difference between list is being passed by reference, but other things being passed by value. So let's actually go ahead and discuss what that means. There's a cute little graphic that I kind of like that I want to share. This little animated GIF. So here on the left is an example where we pass by reference. We define a variable, cup, and let's say it's empty at first. And we have a function fill cup, and here we're actually passing the value in as a reference. And on the right, we pass by value, which is to say that essentially we make a copy of this variable, deal with it internally. The original one does not get modified at all. Whereas in pass by reference, the variable is not actually copied. It's passed as like a, you could say a pointer. That's kind of what the technical term would be for it. But essentially fill cup gets a reference to this variable cup that exists somewhere else. And when we call fill cup, it will actually fill this variable outside. And it's not actually, it's not also a case of it being a global. If I were to rename this to new list, the variable new list would be unique to the function and would be unique to the scope outside of it. They would be two separate things. It's actually that we're passing new list as a reference. So this concept is a little bit tricky to understand, mainly because what values get passed by reference in Python and what values get passed, or sorry, what variables get passed as a value and what variables get passed as a reference. And the nice thing is that there's only a limited amount of variables that get passed by reference. So all we have to do is just memorize the basically 4 or 5 examples, and we know for sure that those examples get passed by reference. But essentially anything that's more complicated than a string or a number, so a list, a tuple, not actually fully sure on the tuple, we might have to double check that, but a list and a dictionary, they get passed by reference, whereas something as simple as a number does not. So if I were to do this, int, let's say new int equals 5, and I would print new int, pass that in here, and instead of returning, I just multiply, and I print new int again, we're not going to end up modifying new int. So as we can see, 5 is still 5. So let's take a quick little look at what is happening when we do this. When we create a variable, just a second, we're going to get a little bit technical in terms of let's think about what the computer is doing when a variable gets created. We're not going to get too crazy technical yet, but let's examine. When we create a new list, this value needs to go somewhere in memory, right? Now, we don't have to imagine the computer has some kind of memory. We've all, or maybe we've heard of this term called RAM, random access memory. I'm sure your computer has 8 gigs, 16, 4 gigs, whatever. You upsold it in the store. They told you need more of it, whatever. Either way, it's got memory that the operating system is constantly hitting. Yeah, David's running on a magical 128 megabytes. I don't even think it's physically possible anymore. Zoom takes more RAM than that. Either way, when we create this, we could say that somewhere in memory, a box gets created, And in this box, we write 1, 2, 3, 4. And essentially new list is kind of an arrow, or you can call a pointer to this box somewhere. The Python, the underlying Python and operating system will kind of know how to deal with this arrow. But when we've created new list, we're essentially calling it new list arrow to some box that stores 1, 2, 3, 4. So when we print new list here, it's accessing from this box. And actually, when we pass by reference, we're not passing the box copying over the contents. We're actually passing the pointer to this box. So this li, when we pass new list in, it actually points to this box. So whatever we modify here, this li is going to point somewhere in this box. This li is going to point somewhere here, whatever. And then we don't actually need to return anything, because this same reference to a box is going to be modified because we're modifying the box contents. We're not creating a new box and then kind of destroying it. So this is what we call pass by reference. And several data types in Python act this way. Like I said, pretty much anything that's not a number or a string will basically act this way. So the primitive types won't be stored in a box like this. They'll just get copied over by value always. So this 5 is one box and it says 5 in here. This box is another box that says 5. This is another 5. And we could reassign values of this box, but simple integers and or strings, whatnot, they won't act this way. Really, the more complicated data structures are going to work this way. Strings are primitive types. Strings are primitive types in Python. So they just made it a little simpler. Well, we can also double check, because I don't want to accidentally lead you astray. Let's instead of double x, let's say add letter and x. Let's do x equals x plus L or something like that. So we have a new int, instead of new int, we have new stir, ABC. We print new stir. Instead of double, we'll add letter. And so if this was passed by reference, line 8 should print out ABCL. But it does not. So strings get passed by value. And yeah, I could definitely send that link with the coffee. Quite a long link. Maybe I should have found a shorter URL of it. Cool. Okay, so any questions so far about this concept? I very much agree. Coffee is, could all use some more. Can I reference how my day was? Yeah, my day was lovely. I always look forward to days that I get to teach. It sounds like I'm being facetious, but I am always kind of excited that I get to go home and teach. Yeah, I turned coffee into code. Okay, so I'm half glad, half worried that there aren't questions. hopefully that means that I've explained this so well that everyone understands this in their sleep. So with that, I actually do want to kind of make this a little bit more complicated. And essentially, I want to explain one more kind of foible of Python that isn't potentially something that's maybe as simple as this. So let me erase this for now. So this was passed by reference. These, when we create a variable somewhere in the computer, it is stored, and new list gets passed around as an arrow to wherever this box is. Now, this next kind of like couple of minutes, don't worry if it gets kind of weird. I wasn't even planning on talking about this in my notes at first, but I thought I wanted to show the true nature of Python and what it actually does. But just so you know, it's like a little warning for advanced content or something. But check this out. Let's define another function. Yeah, I know, the ugly truth. Let's call our function the ugly truth. I like that. Li. Let's make another new list. List 2. And again, let's put just 0 in this. And what we're going to do here is we're not actually going to do anything like append or modify the list. What we're going to do is actually just reassign it. And what do we think list 2 is going to be when we do the ugly truth, list 2? Let's print list 2 again. So the first print we're pretty certain is going to be just 0, right? What do you think line 28 will print? Okay, so Ruben suggested an error might happen. Justin says 0, 1. 0, 1. We got some more votes for that. Yeah, that's definitely what we hope. Christian's got the 0. Dustin's got the 0. Hopefully not, because this is called the ugly truth, and they might have better foreshadowing than others. Scope, that's a good maybe. I mean, the thing is, if I did li.append 1, then I will tell you right now that will work. But reassigning it will do something weird. All right, let's take a look. All right, you guys have guessed enough. There's definitely the correct answer in there. So let's press play. 0 and 0. That's weird, because I mean, if I print li in here, okay, I'm going to print li here, and then we're going to return. It's 0, 0, 1, and 0. And I'll explain, don't worry. It's actually not so bad what's going on. It's just a little bit more annoying. And like I said before, it's actually, if you could imagine the original pass by reference thing, this is just like a bit of an issue with Python. But the original thing is I think enough for us, at least right now, to understand that this concept of pass by reference. So it's actually nothing to do with scope, nothing to do with globals, because we could put all of this, we could get rid of everything else and just have this, and it'll always be the case. So this li is actually passed by reference at first. So let's take a look, right? I'm gonna take out my annotation tool again. So this list li will go to a box, has 0 in it. You know what? I'm going to undo that. I'm going to write 0 in red. And this li points, when we pass it in here, we're passing this, and this li should point to here. So it's weird that this li doesn't reassign this. But because we're assigning a new li, I mean, we're assigning a new li, we're kind of hoping that the value in here should be 0, 1, because we're pointing to the same box. But Python doesn't only pass by reference. The technically correct term is called pass by object reference. So this box model isn't complete, and I wrote this in red for a reason. Every variable in Python will have a box. So actually, what's happening is this arrow over here, this li pointing to this box, it's actually not pointing to that. It's actually pointing to another box that also happens to have 0 in it. Now you're thinking, okay, isn't this pass by value now? There's another box. We copied this. Here's where it gets weird. These two boxes are separate, actually. So that's why when we reassign this, when we reassign, it writes to this box, it writes 0, 1, but then this box doesn't get affected. But then how did the other stuff work? How did append work? That's because these zeros aren't actually in these boxes. These zeros actually exist, this list actually exists in a secret box, which we should call memory. This is actually true memory. And so the objects, when they get created, they live in one place. Python creates the box and then points to it and then gives us a pointer to its own box. So imagine green is Python, red is operating system in a way. If we were to just call append or something, if we were to just call append, since these boxes are both pointing to the same object in what we want to call true memory, these boxes are both pointing to the same thing. So when you do append, you're actually appending to the true memory. But when you reassign, right, when you reassign this, you're not actually reassigning, you're creating a new thing in true memory and then assigning it to your Python box. So you're essentially breaking this link when you create a new variable. And you're putting that new thing into the box. And that is why this li ends up not modifying the other li. Okay. Yeah, so basically, you know how, one way to avoid this, what we should learn from this is not these two boxes. Don't really worry about that, all right? Don't worry about that. Just imagine that everything gets passed by reference and everything is kind of nice and is stored in the same box, right? So remember the first world where it was nice? And essentially just remember, whoops, don't do this. Just don't do it. Just don't reassign your input variables to new things ever. Okay? Just don't do it. It's all, in every language, you should probably not really be reassigning your variables. In Python, the consequence will be that you will get this weird world where you expected one thing, but you didn't get what you expected. So if there's one thing to take away from this last 4 minutes, don't reassign your arguments into functions. You could copy them, assign them to new variables, but don't expect the new variables to be working the way you want them to. But you can in place modify them because they're passed by reference. We could do, let's erase all of this and forget it. Don't worry about it. We can live in the world where both of these point to the same thing, just a box with 0 and 1 or 0 or whatever. And instead of reassigning, we should always just be modifying what we have. So we should always just append, if we want to add 1, just append 1, and we are going to get what we want. Yeah, so Sean, basically append in this case, it's since we didn't reassign, we didn't actually create any new data in new memory. We're just accessing already kind of the same place in true memory in a way, right? Because there's no equals, we're not reassigning, we're not creating new stuff. The worst we're doing is creating this 1. We're not actually creating a new list, right? So before we created a new list, that means that Python and the underlying operating system will need to create a whole new box and put a new thing into that box. But since we're not appending, we're modifying. We might create this 1. This 1 might exist in some box and then get thrown into this box. That's the only thing that's actually being created from scratch here, is this 1 right here. But a list is, no new list is being created. Just a list is being modified. So you can modify your variables, and if they're passed by reference, just expect them to be modified outside of the scope of the function. Almost like a global in a way, but not quite. But when you reassign it, you will get some weird behavior. And seriously, I had to spend like, I don't know, 30 minutes today reading this one article on this. And I've read it probably 4 times already in my life. And I still had to reread it again to remember. Mostly because I almost never encounter this issue because I never reassign my variables. But this is a pretty good article. I'll link it, but I don't like the way the guy writes. It's kind of, I don't know, it's kind of weird. But he has basically the same pictures as me. And I stole his ideas. I just think, like, get past the kind of weird narrative writing. I don't know. He's so I feel like someone who thinks a little too highly of themselves. But the rest of the actual content is quite good if you want to read more on this. But golden rule, as Justin said, don't reassign variables, and you're not going to get in trouble. Cool. Ronnie is a madman. Okay, cool. So glad we got that out of the way. That was nice. Aren't we excited about the rest of our computer science curriculum? I'm just going to comment this stuff out. Yeah, I think this next thing is going to be a little easier, but if not, we're about to go to a break anyway, so don't worry. That concept is genuinely one of the harder, definitely one of the harder things to understand. There's like a lot going on, and you have to have like layers of knowledge, or like layers of short-term stuff in your head, like what's going on in the computer, or what's going on, whatever. So if you stick to the golden rule, you don't have to think about nearly as much. And that's the beauty of Python, JavaScript, all these higher level languages. We just want to think less. Thinking's hard. Cool. Okay, so let's talk about arguments, and then we'll take a little break, and we'll do a programming challenge together. Cool. So here I have this line. Write a function, print 3 numbers that prints all numbers in the order they're given. Amazing. This is actually hopefully going to be a lot simpler. So here I have an example. Let's define it. And let's call this number 1, number 2, number 3. And let's go ahead and print. We'll use some fancy F strings. The first number is, or let's make it number 1 is number 1. Copy that over. Oh, a lot nicer, huh? Getting a little syntax error. What's going on here? Let me run this and see what it's going to complain about. I'm going to comment out the rest of the code and then we can re-enable it later. What am I doing wrong here? Am I doing my format strings incorrectly? Wonder if it's accidentally, oh, you know what? Okay. I think I might be in a wrong version of Python. Let's just try that one more time. Python 3 function. Okay, cool. Yeah. I think I accidentally installed a plugin because I don't use this too often, so it likes to suggest me plugins to install. I think I installed a plugin that gives me Python 2 errors. Oh well. Okay. So either way, easy peasy, nothing too bad. We're all masters of format strings now, and this isn't entirely shocking for anyone who because we've already done many different functions in JavaScript. But essentially, you need to pass three arguments. You just go ahead, name them appropriately, pass them in like this, and you could use them quite predictably. Let's take a look at some other ways we could pass arguments in, though. So named arguments. This is pretty cool. So this is called positional over here, 1, 2, 3. And it's positional because the value of each argument up here is linked to the position in where we call them, right? So 1 is linked to number 1, 2 is linked to 2, 3 is linked to 3 because it's all in order. If I change this to 5, number 1 is still 5. That makes a lot of sense. Named arguments are something that's also pretty cool. And we could do this. We could actually do number 1 equals 5, number 2 equals 2, number 3 equals 3, and run it that way. We'll see, print 3 numbers. And we will see that it will also print us what we expected. This is called named arguments. Yeah, 1, 2, 3. This, and you could probably tell right away why it's called a named argument. We're literally naming the argument and we're assigning it some value right here. So this is kind of the syntax for this. But what is so special about this? Let's take a look at using both positional and named arguments. So let's do print 3 numbers. Let's do the first one as positional, the second as named, and the third as named as well. Let's run this. Comment out this. Okay, great. Everything makes sense. Number 1 is 5 because it's in that position. Number 2 is 2. Number 3 is 3. Makes a lot of sense. What if I did this? So now, whoops, I deleted by 3, put it back to 3. Okay, so now we have 5 in the position, but then we put number 3 here and number 2 here. Let's see what happens. Number 1 is 5. Number 2 is still 2. Didn't get set to 3, even though 3 is technically in the position. And number 2 is set to 2. That's because both of these are named appropriately. They take we assign them to the right value. So we can actually mess up the position, but still get the same correct values that we want for the correct variables because we numbered them all. Let's see what happens if we number 1 as well. Number 1 is still 5, number 2 is still 2, number 3 is still 3. That's great. What if I got rid of that though? What if I had two named arguments and then a positional? Will it know what position this is going to be in? Because technically it's in the 3rd position. So let's see. Yeah, we're getting the error. So we can't actually do this because let's think about it. I mean, in our heads, what do we want 5 to be? Do we want it to be number 1? But we put it in the position of the 3rd variable. And since we are confused, since we don't even know, the code says, I don't want to take guesses. This isn't my jam. If you're going to name an argument and then you're going to put a positional argument after it, I'm not going to try to guess what you're trying to do. Are you trying to put that into the first unnamed position? Are you trying to put it in the correct position? Not up to me. I'm just going to say syntax error. You cannot write positional arguments after keyword arguments. So you can write an unlimited amount of position arguments in the right order, and then you can write an unlimited amount of keyword arguments, but you can only write positional arguments at the beginning, and then you can write named ones. So why, I don't know, why even bother? Who cares? What benefit are we getting from doing number 3 here, number 2 here? And that's actually because, well, laziness, yeah, but I almost would argue that it's easier to just like know what position things are in and name them accordingly. So let's say this is number 2, number 3. Oops, number 3, yeah. Actually, the cool thing about this is optional arguments. So let's say we have 5. If we did this, we just printed 5. We didn't put a value for 2. We didn't put a number for 3. Well, okay, we actually got an error. That's pretty good. I realize actually that I'm jumping ahead of backtracking. Forget that part. We'll explain that in a second. But yeah, either way, just this is another way to define, to set your arguments. You can pass in a positional and a named one. Yeah, exactly, Tristan. You can't do that. You can't set number 3, put 5 here or 1 here, and number 2, it's going to complain. Because again, it doesn't know, are you trying to set the first one? Are you trying to set the second one? But there's already a second named one. Why bother? It doesn't, since it's already ambiguous to us, it's going to be way more ambiguous to a computer that doesn't have like our intuition for things. So this is named arguments. Oh, okay. Good point. Good point. I see that what you're saying, but it's still not gonna work. It's still, it's easier to just blanket statement say you can't do that and forget about it. Cool. All right. Now let's take a look at this requirement. Write a function called print all numbers that'll print any amount of numbers. So any amount we pass in, it's going to print successfully. So this one's a little bit trickier. We could maybe find a way to like figure out, I don't know, maybe we could do something like print all numbers, and then we could see like how many arguments are passed in, and then maybe we can call like different functions or something like that. But actually there's a special thing that we could do, and Isira already beat me to it. But let's say we define args, so this is just whatever arguments you pass in. If we add a star to them, we unpack this. So we talked a little bit about unpacking unpacking values before, but essentially this is what we are doing now. So let's actually first just print args. So we've unpacked it. Let's see what args is going to look like if we pass in just one. It's going to turn all of that into a tuple. So this is called star args. You're going to do this in your assignment. And let's take a look at what happens if we do 1, 2, 3, 4, 5. I think we can already expect it to be a tuple, another tuple. Notice that it turns into a tuple, not a list. It's very smartly turning it into something immutable. Because remember, we don't want to reassign our arguments. There we go. So now this is actually just a pretty simple thing. For I in range length of args, you just go ahead and print num at I is args at I. So if we go ahead and do that, whoops, for I in range. Actually, Justin, I think it's faster than a list. Tuples are faster, but that's not really something that we need to worry about too much, in my opinion. But it is faster because a list actually needs to store the same amount of data plus a little bit more about the list. Again, I don't want to talk about more boxes yet. We're gonna deal with that in a couple of weeks anyways. So I'm gonna save you the pain right now, but you can imagine they're faster. They have to store more information, essentially, a list. Cool. So as we can see, we ran the first output, second output, third output. And we have all kinds of different amounts of args, and yet we still are able to process this all with one function because we use this star args and unpacked all of the arguments. Cool. What is the difference between args and star args? I was really hoping no one would ask me. Levy, yes. Is args a foobar name? As long as a star is in front of it, allow you to have any arbitrary amounts of arguments. Yeah, so it's going to turn your arguments into a tuple. You can call this whatever you want. Numbers. So I'm not sure if that's what you meant by foobar name. Yeah, like you don't need to call it args. Args is just kind of like the easiest way to learn about this is you type in star args in Python because star args is kind of the way. Like if you look at this, it's kind of the typical way of like I don't know. It's nothing really special here. They have argv, whatever. So you can call it whatever you want. But actually, I'd like to answer the star. Oh, Yasir is already ahead of me. It's for named args. Cool. Yes, it's for named args. And I am going to be that annoying teacher and say, I will leave you to learn about those in the assignment. Because I can't take all the fun away. But there is another notation. You can have 2 stars, and in your assignment, you can learn more about it. This Geeks for Geeks page is actually pretty good at explaining it. Cool. So, any more questions so far that Yasir can answer for me? Yeah, Jordan, for sure. So which function? This function, right? Yeah. So let's say we have numbers just as one variable here. If we want to print numbers, we're actually going to run into some issues when we want to run this. So let's try running this right now. We have, let me comment this out for now. So right now it prints 1. That makes sense, right? Because this is just a regular variable, and it's assigned to 1. But if we define this variable with a star over here, it actually will treat all of the input in here as a tuple. So if we print this out now, notice that it's not the same thing anymore. It's actually a tuple with one element. So we can actually run this. We can do 4 range length numbers because it actually has a length. It's a tuple object. And it'll loop through the length of the tuple and run this, in our case, just once because there's only one element. But when we do this, because this is now turning all of this input into a tuple, it will print this out, or we'll see that it will print as a tuple. But if I didn't have that, first thing will work, but the second won't. So because it says takes 1 positional argument, but 5 were given. So in this case, numbers is just supposed to be 1 positional argument, but here now it's saying I'm accepting an unpacked tuple. So it's a little weird, but essentially it's saying that you could provide me a list of unpacked values, and I know that to turn it back into a tuple. Essentially, if I were to have a tuple, let's say num tuple 1, 2, 3, 4, 5, I could print num. Let's print num tuple. So honestly, like I'm going to explain this. It might still seem confusing. The bottom line is it's best to just remember that star will basically allow you to, like, it's essentially like ... args, like the way Tristan said in JavaScript. Yeah, it's pretty similar to like the spreading. But I do want to show this real quick. Let's say we want to spread tuple. So let's take a look at what num tuple and star num tuple will turn into. Print like the first thing is just a tuple. The second is the spread kind of notation. And I think if we doubled it, let me see. It doesn't work. I was hoping it would reverse it, but essentially it's like this process is kind of like reversing this back into this. So it's almost like this is the unpacked and it's sort of packing it back up. But you can treat it like a spread operator. You'd pretty much be thinking of it as a spread operator. Yeah, or like ampersand in Golang, although I don't know Golang. So I'll trust Dustin on it. Okay, cool. So sweet. So any more questions so far? We're going to take our last concept and we'll take a quick little break. You guys keep saying that, and you're gonna end up starting to run my instructor hours. Cool. Okay, I see other people are typing. I'll let you guys ask questions, and let's get on to the next concept. And if there's questions about the other stuff, we can talk about it kind of during the break or something. Okay, last thing, write a function that will print all numbers, but it'll also print it in reverse order if we say reverse true. So we're now talking about optional parameters, and this is actually something that JavaScript also kind of has. But only in like the newest versions of it. But let's take a look at what that looks like. Let's copy our trusty function that we know works super well. And let's call this maybe reverse. And now, instead of just star numbers, we can actually also add another variable. And we can actually, instead of just ending it here, we can also say a default value. So right now, if I do this right here, I pass in 1, I pass in 1, 2, 3. I go ahead and run this. The first output is that. Second output's 1, 2, 3. If I want to print this, I don't think we need all of these. We want to print 1, 2, 3, 4. But we also want to reverse it. So since the reverse is passed as true, we need to modify this code a little bit. So a really quick way to reverse a list is to do this weird notation. Don't worry too much about what that is yet if it looks confusing, but essentially it will reverse it. So now if reverse is true, we reverse. And here I know I'm doing a horrible thing. I'm reassigning the argument. I really shouldn't, but I guess maybe it's okay in this case because I don't actually care about what happens to it. But I'm doing a bad thing. Let's take a look. Oh, good, and it doesn't work. Perfect. All right, because numbers. Yeah, I know. We're not thinking about the boxes right now. We're just doing it. Cool. It worked. One thing we have to think about, though, is what happens if I don't name reverse equals true in this case? Sorry, what happens if I don't pass it as a named variable is what I mean, a named argument, if I just do this? Yeah, it's gonna get unpacked into the numbers. So num at 4 is true. So it got added there, and it did not reverse. And so this is another kind of important little tidbit. This will be all your positional arguments. You can't have numbers and then args or something like that. It can't work that way. Exactly. And that's why naming it args is great, because it is all your args. But you could name named variables, but you can't do this either. So you can't actually do this because reverse is missing. And it's a keyword only argument, actually. So Python actually knows this in this specific case. It actually says keyword only. You have to define it like this. Oh, and actually the reason it didn't work is because it's missing here. I name changing things too much. Cool. You have to name it, or in our case, we can also just add a default value, and in that case, Python is happy. We don't actually need to add it as a variable anymore. Cool. Okay. So to recap, pass by reference, honestly, a great uh, way to learn pass by reference is inevitably forgetting that it exists and thinking, why is everything changing when I don't expect it to? And then remembering, oh, right, Python has this one weird thing. What's the weird thing? Let me go remember it and kind of repeat the cycle until it sticks. And um, there are multiple ways to pass variables into functions, uh, and the differences are positional and named arguments. Yeah, this one weird trick will make your memory management in Python much better. Okay, cool. We've been talking for a while. Let's take a quick little break. Yeah, Roddy, that's true. I just described exactly what every engineer goes through all the time. I'm going to set a timer, but I'll stick around and answer questions. For anyone who wants to take a break, I go ahead and take a break. Sorry, we're I think a little bit. I don't want to take too long today. Oh yeah, I probably could. Just a good idea. Okay, Reed, you have a question. Line 57 would set default reverse to false, and 65 would overwrite that to true. Yeah, exactly. Yeah. So it's right here. We've set the variable to false, but if you ever whatever is here is going to overwrite any default values.
And you could essentially leave out. You don't need to put in the reverse equals true on 65, right? Because you have the default set in 57.
On 65, yeah, I don't have to have this line, but
Yeah.
I do
So
want
like for whatever reason, you could like, so if you changed 57 to true now, it would be 4321, right?
That's right. Yes.
Yeah.
So
okay.
if I set this to true here, then but then all of these will be reversed, and so
Yeah.
instead I would have to do reverse false, for example.
For those ones, okay.
Yeah.
Cool.
Also, is it Levy or Levy? I know there's two ways to pronounce it. But to answer, okay, cool. First one, Levy, you can't have star arg and star arg, so don't worry.
Thank you.
Ooh, John, I wish I knew. But unfortunately, the Earth is going to blow up 6 minutes before the answer is finished. Oh, Steve, by the way, you asked, how did you get VS Code to change version? I didn't actually make VS Code do anything. I just exited my environment. I kind of did a pretty lazy, thing. I'm not in an environment right now, just using regular Python. You saying you have a syntax error there. I would double check what version of Python you're running that in. I guess it says Python 3.8 at the bottom, but maybe what VS Code is executing with isn't. I'm not fully sure if I know. I'm not that great at VS Code, to be honest. But maybe the shell here or something can say Python. Yeah, see, mine says Python here now. And now mine's breaking, so I'm not sure fully. Yusira, I wasn't going to talk about variable scoping here because it works the same as in JavaScript. I guess that's a bit of a cop-out. I wasn't actually going to plan to talk about variable scoping. But if that's something you're gonna have to deal with that in the assignment, and if that's not enough, if people are confused about it, next week we can go over any assignment one things before we move on. But you're going to and if you're thinking of closures in the same way that JavaScript does closures, it's not quite the same. closures are a little bit more special in JavaScript, I think, or at the very least, people generally don't do that kind of stuff. Because closures are very like functional and kind of very JavaScripty. But there's, yeah, don't really need to do that stuff. I will be right back. We have 42 seconds left for the break, and we'll resume in a second. All right, I'm really sorry about that. I didn't realize that I was sharing with the audio as well. Oh, a lot of lovely technical things I'm learning about Zoom. I apologize for that. Okay, so let's get to the second part of the lecture, which I think is going to be quite fun because we're all going to work together to solve our first kind of programming challenge. So first, who have you guys had the chance to read about the Lambda problem-solving framework? So yes, if you're confused about it, I will link it after class one more time. I think I apologize if people have missed it, mostly because we kind of added it to the curriculum fresh this time, and it's possible that maybe your material is not fully updated at the moment. But we'll go over it anyways. So the Lambda problem-solving framework, essentially, it is kind of a step-by-step process for us to think about problems that we encounter. And I mean, it relates very strongly to engineering problems, but really it could be applied to many things in life. But essentially, it's a series of 4 steps that help us kind of approach a problem, understand it, solve it, iterate, and at the end, kind of truly understand and conquer the problem. So let's kind of go over the steps together. What is, and I will actually close this right now, but what is step 1? Of the framework? Yeah, thank you, Justin. So the first step is we want to essentially understand, right? We want to identify the problem and figure out what is there to know. So step 1, understand. What does it mean to understand the problem? Also, yeah, this is very heavily influenced by Polya's technique. In case you guys want to go take a look at that, it's possible that we still have videos referencing Polya's technique in. The biggest difference between the two is actually, it's very similar. We just wanted to word this into something more relatable for us because Polya's technique is something that's kind of very general approach to problem solving. And yeah, sure, I can explain who Polya is real quick. Polya, forget his first name. I think it's David. I think it's David Polya. And essentially, this was he was or is a professor at some fancy university, but he came up with this kind of four-step process to approaching any problem, and kind of quantified the individual steps and goals at each step. And okay, cool. Yeah, Polly's technique was covered in the lectures. I think the goal is to eventually actually replace the material with basically what I'm talking about. But essentially, it's the same idea. We're just I think the biggest reason for the change is we want to think about these steps in kind of a more technical perspective. But essentially, it's all the same. So let's go back to understanding the problem. If we need to understand the problem, this is kind of the question asking period for us. So what kind of things do we want to understand, and what kind of questions might we want to start asking? You're asking to yourself, to maybe the person who posed you the problem, to the universe. Yeah, cool. What variables you might need? That's a pretty good thing. Although let's skip what variables, because variables are kind of like solution parameters, right? We want to think about the problem. If we never had to come up with a solution, we probably don't care about variables, right? So yeah, Rain, that's a great idea. Inputs. What are we given? Inputs. And you see your constraints. Dustin, are you asking what is the actual problem, or you're saying what is the problem is the question we should ask? Okay, yeah, sure. Let's say that we've asked that and we've gotten the problem ahead of us, but we need to probably ask more, because chances are we never get the full picture on the first try, right? Constraints are great. So, for example, spelled constraints, constraints, right? Yeah. So inputs, what are we getting? Constraints, what will the input ever have negative values? Basically the rules, yeah, like rules on the constraints, on the input. Those are absolutely fantastic things to understand. Cool. Maybe we can ask some technical things like how fast should we be able to solve this, right? Do we have, is it a function that can run 5 days? Or is it something that needs to be very quick? And can it be, maybe we can take up a lot of memory on a computer, or maybe we are, we have a lot of memory or something. Yeah, 5 days. Well, if you think about 5 days, when I say that, it also could be like a client's problem, right? A client could come to you and say, hey, I need to come up with this solution. And maybe you need to solve it in 2 weeks, or maybe you need to solve it in 4 months. And in 4 months, maybe they expect it to be super polished, something like that. So Dustin, that's a great question as well. Who are we solving it for? Not all these questions are super necessary for every single problem, of course, but the point is to be very, very general and very specific at the same time. Who are we working for? Or who are the stakeholders? Edge cases. Yeah. What's an edge case? No one ever asks that. What is an edge case? Yeah, these are the case. Yeah, they're outliers. They're edgy. Either way, yeah. So you might think edge case empty arrays, for example, kind of like constraints that you might not think about. Definitely. Awesome. Abnormal stuff. Yeah. Get as crazy as possible. These are also great questions to ask in interview problems and these kind of challenges as well. Okay, cool. So I think we've covered 99% of what we need to understand. What is step 2? Yeah, let's plan. So now here, I would say that it's probably pretty good to maybe think of the variables, maybe think of variables, because I know someone said that. Think like a villain. Yeah, Jordan, what does it mean to think like a villain? Well, okay, John, hold on. We're getting a little ahead of ourselves. Let's not solve this exact problem yet. Maybe I shouldn't have shown this, but keep that in mind. Yeah, pseudocode. Oh yeah, that's a great idea during planning. Yeah, how do you want to cover those edge cases, right? So we might want to think of the general code, but maybe the edge cases we want to deal with in specific ways. Handle edge cases. Yeah, we might want to break things up into little steps, kind of step by step. Another very useful thing is, should we spend too much time here? Should we like devise the most ideal solution? Yeah, maybe we should have like a first pass, a rough sketch, right? Like, what if the problem isn't solvable, right? We understand it, but what if it's impossible to solve, right? Maybe the question is, what is love? And we don't even know how to go about solving that. So maybe it's best not to spend too much time on the first pass, and take a stab at kind of like a generally good approach. So let's say. Think of easiest uh, kind of, I want to say almost brute force in a way. Keep it simple. Cool. Okay. So we've understood, we've planned a pretty decent solution. We've convinced ourselves that our pseudocode works. Uh, what's the next step? Hands on keyboard. Yes. And then what do we do with those hands? Yeah, we want to code the solution out. Let's actually go ahead and implement it. And now, obviously, what are the kind of things we should consider when we want to actually go ahead and implement the problem? What are maybe some questions we want to ask ourselves in this case as developers, as people approaching a problem? We've kind of modeled out a solution. Yeah, tech stack. That's a great thing. So maybe we want to ask ourselves kind of language, right? I'm going to spoil it for today. We're going to use Python. But in general, great question. What is the kind of the best tech stack? Maybe there's better languages. Maybe there's like frameworks, things like that. Yeah, data types. What kind of data types do we want? Uh, Data types, data flow, all that good stuff. Data types. Definitely. Do we want to use an object? Do we want to use an array? Do we want to use a mix of both? Is it worth turning the array into an object, or is it worth turning the object into an array? Right? Um, sure. Okay. Christian, that's a good point. Maybe some of these could be in the plan. Tech stack. I guess you could also put that in the plan. I would probably say, you know, I don't know. That's a tougher question, I guess. You could also just say maybe we can scope execute to pretty much just build and build, right? Yeah, I mean, the edges are kind of fuzzy. As with every kind of mental model, we're pretty much going to end up having more of like a spectrum of process than we're going to have like very definite moments. But definitely, thinking about tech stack in either the execution phase or the planning phase, as long as we think about it. Maybe we could think about some coding practices, right? Like, how do we want to structure the code? Maybe we want to have classes or functional programming. Maybe we want to make sure we're documenting or testing or something like that. But we are also trying to keep it simple. So we want to make sure that we're not writing bad code, but we're definitely kind of writing code to learn. Yeah, definitely spaces over tabs. Yeah. Yeah, I definitely want to one-line it. So, other things to consider, maybe add some tests / documentation. As you're writing the code, you're already in it. It's not a bad place to kind of document as you go. And maybe also keep it dry. So do not repeat yourself, right? We want to make sure that as we're coding, again, it's great to come up with a hacky solution to prove and then refactor. That's perfectly reasonable. But at the same time, we don't have to write bad code for the sake of writing bad code. It's always easier to refactor good code into better code than it is to refactor really bad code into slightly worse code. So definitely keep in mind good practices, but take it easy. Yeah, and also don't overdo it. That's a good point, Dustin. Don't keep it readable, document, but at the same time, our goal is to get the job done right now. Okay. And now that we've finished our first pass, we've ran it, we got some output. What do we do next? Yeah, we want to go ahead and reflect. What are we reflecting on? Our life choices. Don't think too much. Yeah, we want to think, is this the most optimal? Is this the most optimal? You're right. How optimal? Jordan's got a good idea. Are all cases covered? I mean, another thing that could go wrong is, what if we didn't ask enough questions? Maybe that's where we find that all cases aren't there. So maybe we want to put it in front of the user, see how they react, test it out, right? Realize, is it good for what they wanted? Were there some hidden kind of expectations that we didn't meet? If so, what went wrong? What can we fix for later? And specifically for this, we want to test here as well. Performance is something we want to talk about. We're going to learn a lot more about performance as we go through the CS curriculum. We definitely want to make sure, is the code optimal in the sense that, is it performing as good in like the worst case solution as possible? And then after that, we might want to just go ahead and repeat, fix things up, reflect again, plan again, ask more questions. And this process kind of essentially repeats itself on a loop until we have nothing else to reflect on, or we have run out of time in both the interview or in life. Yeah. A very good thing to remember is coding, as many creative processes is an incredibly iterative process, and we can't get anywhere without stopping, trying, testing it out, seeing if it works, if it doesn't. And if you notice about when you're actually doing any of these steps, there might be like a small recursive plan. You kind of break little things into a plan, test, repeat. You might even plan and execute in your head potentially and realize that the idea isn't going to work. And then you reflect and you go back to planning and you don't even write the code. Eventually you kind of know how your code is going to go, and you probably don't have to execute it to realize. Um, and it sort of repeats itself over and over like that. Okay, cool. So I think we all understand this process. Let's actually go ahead and implement it for this problem. I'm going to wipe the board and give you guys a minute to read this problem, and then we could go ahead and go through the 4 steps and see how we do. Okay, so our goal here is to return the centered average. So reading the question, we get the idea that we need to return the average of the values, except we want to get rid of the largest and the smallest values from our array. And if there are multiple copies of the smallest value, ignore just one of them. And likewise for the largest value, same thing. And we can use integer division to produce the final average. And we also have this line, you may assume that the array is length 3 or more. So let's think step 1. Excuse me, step 1, understand. What do we know and don't know about this, and what do we need to clarify? There shouldn't be too much stuff. John, I'll give you the cue. Yeah, so the input is an array of ints, so we know that for sure. It's an array of integers. We don't have to worry about strings, so that's pretty good. It's always going to be ints. What other things do we know about the input? Yeah, and we know it's length 3 or more, so we don't actually have to worry too much about the length, and that's going to be good because we don't have to worry about these edge cases. Oh yeah, Reed, great call. Not sorted. It's not sorted. So that's pretty good. That's a great question to ask often, is like, is it sorted? You know, because I could see John's solution is going to include one version of that. We also have negative values. That could be something, but I don't know, probably not a huge deal. I would say it's probably not a huge deal to wonder how big an individual value could be. We see 100 here, but probably not something we should worry about. So I think this looks good. Oh yeah, you can have duplicates. Yeah, so there's duplicates, has dupes. So we have to deal with them. And yeah, we could ask even or odd. It doesn't say anything about even or odd, so I could imagine that they could very much be even. So we have to deal with potentially getting the average of an even set, which, again, shouldn't be too bad. Cool. Any other ideas for the understand part? Yeah, Isir, a good question. You can assume the input to be a flat list. It'll just be a list of numbers. Yeah, Ronnie, you know, when you said even, I also thought, wait, are we doing median? But luckily we're doing average, so it's going to be fine. Okay, cool. So, all right. Now the step we're all waiting for. Go ahead, paste the same line in, John. Planning phase. What do we want to do? So we have a couple ideas. Just gonna give John the credit for the first plan. He's got a great idea already. So we potentially might want to sort the list. Sort it Create a set. Okay. What do we want to do the set for? Rain, the problem it's not to discard dupes, it's to ignore just one copy if there's duplicate smallest values. So it says multiple copies here. So like here, there's 2 ones. So we just want to get rid of one of the ones and keep the other in the average. So we actually probably don't want to remove all the duplicates though, right? We just want to get rid of the duplicate that is the first, or if the duplicate is the smallest value, we want to get rid of it, or if it's the biggest value. So one thing, sorting a list actually does help though, right? Because it helps us find the smallest and largest value. Okay, so hold on just a sec. Let's take a look at everyone's throwing out a lot of great suggestions, but let's basically go. We can sort the list, and that could help us find the min max, right? So actually, if we get rid of the sort list thing for now and really think about what we're trying to do, we're trying to find the min and max, right? So we need to find, min max. So we could sort the list for that. There's also some other ways we could do that, right? Yeah, so Reed has a solution. I think that might be what John was suggesting too. So sort and then remove first and last. First, last. Cool. So that's one way. Yeah, Christian has another way, or Yasir and Christian both kind of say a similar thing. We could just we could use min max method. So that's a good one. Min max. We could also just loop through the array, keeping track of the smallest number we see and the largest number we see. So that's pretty good. Min max will do that basically. A min will just go through the whole array and find the smallest number. Max will do. You could do 2 iterations. You could also just do it in one, keeping track of 2 variables at the same time. So we could loop in array. We can either do two loops or just one loop. One loop can work as well. So let's say all of these are pretty good to find the min and max. Do we have any better way to find a min max than either one? This one is, which one's like the best option, I would say? Yeah, I think this one's pretty good. So why is min max potentially better than sorting and popping? Yeah, so in general, sorting, sorting is always going to be a little bit slower than just like looping through an array without sorting it. So in general, sorting is going to be a little bit slower. But it's also a valid idea because also at the end, we will have an array where we have removed the first and last. But yeah, so Reed and others have suggested that it's a pretty good idea to sort because you can already have kind of the final list that all you have to do there is just sum, right? So once we have those, we need to find the average. Or next step is we need to remove those values. Remove min max, I should say. And then we need to find average. So min and max will basically do this loop already. So we definitely don't need to loop inside loops too much for this, or at all, we hope. So sort is kind of unneeded if all we're trying to do is find the min and max. But we still have to remove them. So we could do what Steve suggested. So we could just find the value and just delete it from the array, and that'll work. So we could just delete it, dot remove. Yeah, we could use the built-in remove functionality from an array given the value, and then that should work. So that could work. And then finding the average also, I think finding the average should probably be pretty straightforward once we already have the min-max, removed it. Finding the average, we just need to go and I guess sum what's left. Yeah, sum the rest. And also, what do we want to do? We want to sum the rest, and we want to divide it. Okay, so I apologize for my writing, by the way. Okay, so we have a pretty solid plan, but I already do see, since we have the brain power of 60 people in this room, we are also coming up with some pretty great solutions for the planning stage. I wanted to kind of go through step by step for us to iterate on this, but a lot of people have thrown out some even better options. So let's kind of take a look where we are. We could execute on this. So we could write this code. But I have already seen some people suggest some kind of mathematical ways. So we could take a look at that as well and see if we can find an even better solution without even executing to begin with. Although that being said, taking these steps and running it will already allow us to find a pretty solid solution. So we could also execute. Do people want to see us code this up? Yeah, I say let's code this up first, and then we could talk about, because I definitely have seen a couple of people throw out kind of the more some more concise solutions, but they rely kind of on more like math trickery. But let's take a look at this. Okay, so let's actually see how easy it is to execute because we've already made a plan. So we need to find min num, and we already know that min nums. We can just do that. Max num. We could just do max nums. Like I just have to look at my pseudocode to basically do all of this. Let's say filtered nums equals, or maybe wait, we just need to do the delete. I guess we could just go ahead and do delete nums. Someone wrote it. Help, yeah, there we go. Delete nums index. Is that, how do we find the index of a value in a Python list? Someone help me out. Or just use remove. Yeah, will remove take a value? Is that what remove does? Good question, Rain. Does remove all? Let's consult our docs. And we're going to have to deal with this stuff over here. So it looks like it just removes a single element from this little blurb. So I think we'll be okay. We could try it out and see if we get an error, and that'll be our iterating stage. Nums dot, let's see, remove max num. Cool. So now at this point, we just need to get the sum, let's call it S sum, or we could literally just go ahead and do return I realize that other people could draw on this, but please don't. Return sum nums, divide by the length of nums, and let's press go. Awesome. All correct. So, oh, why not mean? Oh yeah, I guess we could just do that. Sure. Is there a Python mean list mean function? Let's see. Okay, cool. I didn't even know that. So I could just, okay. Oh wait, so I have to import it, it looks like, right? We might be able to import it, but it's possible that this environment might not allow it. So that's a great idea though. I mean, if we know of a better library to help us out, that's also very good. A good question to ask is, are we allowed to use other libraries? Oh wait, let's see. Code should not use print or import. Okay, so see, in this case, we have a constraint. So it looks like we're not allowed to import, unfortunately, but that is the constraint that was given to us. I know. Cool. Okay, so now that we've done this, our next step is what? Yeah, we want to test and we potentially want to make it better, or we need to reflect right now because who knows, maybe we nailed it on the first try. We very much could have. In fact, with the brain power in this room, we absolutely, in my opinion, came up with mostly as good of a solution as it gets. But there were a couple of people that suggested a slightly better solution, and we could take a look at that one now. So let's see what's potentially not good about this. I mean, it's pretty innocent, but we do have a min num, a max num. We're calling all these removes. So when you remove from an array, you have to essentially kind of traverse through the whole array. You have to modify. So is it possible for us to maybe get rid of these removes? We could say we're iterating too many times, but I mean, that we could maybe find min and max in one go, although we now kind of make our code look a little bit worse than just saying min max. Like this looks better. But yeah, Isira, you got a good idea. Sum the whole list and subtract min and max, right? We don't have to do the removing. We can just do the math in one go and just remove via math instead of more costly operations on an array. Totally. So if we want to say, so really we just need to do sum nums minus min num minus max num. Get rid of this. And let's press go. Oh no, what did I mess up on? Sum. Oh, sorry, -2. Length. Oops. Getting all of my bed mess wrong. Here we go. Awesome. And actually, this is kind of only really possible, I guess, because we have this assumption too, right? We can assume that the array is like 3 or more. So it's pretty nice that we don't have to divide by a negative number, or dare we have it a 0, which would absolutely break our code. Cool. So this, we've iterated, we've coded up a pretty solid, pretty quick solution. And as we planned it out, we kind of did all the hard work already. We scoped the problem out. So when it came time to execute, we pretty much had to spend no time thinking anymore. We were the robot coding a robot at that point. So really, step 2 is what separates us from the machines. Yeah, we could also just make it a one-liner, totally. Oops. Although at this point, we might make the argument that this isn't better. Justin, yeah, what about arrays and arrays? We discovered in our first step that we don't have to worry about such input. We won't have that kind of input. But if we did, we'd have to tailor our problem to something else for sure. Okay, cool. So hopefully that was a slight intro and a taste to kind of the power of this process. It's interesting when 64 people or 60 people at the same time approach it, because the planning stage ends up becoming super efficient, and you might find yourself discovering everything there is to know about the problem pretty quickly. But in general, anything could. Our first plan started off as, so we've suggested sorting, we've suggested summing or iterating, we've even suggested for loops, but we ignored that suggestion. Either way, we clearly had to do a little bit of thinking, but when it came time to execute, we discovered that the solution was almost good. And then when we iterated, we found that there were maybe a couple more things that we could optimize, or we could find that, hey, well, these removes are here. I mean, it's not such a big deal, but maybe we really want like the most optimal solution. So we had to think about that and think, okay, the removes are not going to fly. And we figured out a way around that as well. Yeah, and that too, when you like explicitly separate the steps into an understanding, a planning, and an executing, you could kind of already start to see the perfect solution form. And when you don't see the perfect solution form, that's why it's great when you break down these problems, because you have a great formula to get to the best solution eventually, right? I don't know how many people relate to this, but maybe when they saw the programming challenge, or even if they've had an interview or anyone ask them a technical challenge and you kind of freeze up because you're not quite sure how to proceed. That's because maybe it's possible that you're trying to come up with a solution very quickly and show that you know what you're talking about. But really, it's best to step back, ask all the questions first, right? Give yourself some time to think about it. And when you plan, you can iterate it through the planning process before you even execute. When you execute, you get to learn even more stuff. So it's a constant kind of evolution of learning. And we are going to essentially employ that in pretty much every kind of process that we embark on in this curriculum, in this course. Okay, cool. We have a few more minutes left before we're going to end for tonight. Any more questions about everything we talked about today? Also, I want to give a shout out to this group, not to disparage the previous group's performance. They were a smaller group, but no one actually came up with this mathy solution. So congrats to you guys. Tristan, that's a good question. Honestly, I don't really know, because I don't really know too much of the operational side of some of this. So yeah, so just ask your TLs, and they're very good at like digging down and asking the right people. I'm just a person who executes this curriculum. They just well, I only had one group before PT4, but I don't choose favorites. Yeah, I'm just a guy working here. I don't know these answers. I'm pretty sure was that I don't know who drew it. I think I realized other people can draw on this. Okay, cool. This was super fun. Thank you guys for being here today with me, and I will see you all on Monday, where we're gonna start talking about even more complicated, not more complicated, but even more interesting concepts about Python. And then after next week, we'll dive into some real CSE stuff. Cool. Okay, great. And thank you for participating so actively in this chat. All right, I will see you guys all next week.